Hello, everyone. Welcome to our first Angular Kenya webinar of 2026. My name is Joy. I'm the co-lead of Angular Kenya. I'm really happy to see many of you joining us today. So today we're kicking off the year with a session about comparing promises and observables and signals by Lance Finley. So I'll let Lance get started on it.
All right, thank you. Can you hear me well? Just before I get going, I want to make sure we're good. Okay. All right. So hello, everyone who's watching. I have this slide here. I'll have it at the end with the link to the slides so you can see that later. And I'm going to be talking about comparing promises, observables, and signals. Now, my name is Lance Finney. I'm from the United States. I work at a company called Infocon, and I'm a Google developer expert in Angular. And I've been working in Angular for over 10 years and have been a conference speaker for a couple of years now. And since I'm speaking to people in Kenya, you probably don't know where I'm from, a whole lot about us, but perhaps you have seen this thing before. This is the arch. This is the most famous symbol of the city where I live, which is St. Louis, Missouri, right in the middle of the country. We're right on the Mississippi River, which goes through the middle of the country. And this arch is a representation of St. Louis's history as America grew. It's about a 200-meter high arch. And now I'll get going into the talk itself. So the too long didn't read for this talk is that JavaScript has three types of reactive primitives. The first one, the oldest, is promises, which gives us single value asynchronous reactivity. There's also observables, which also gives us asynchronous reactivity, but 0 to many values. And it's more powerful, but it's sometimes overkill when all you need is a promise. The new kid on the block is signals, which gives us synchronous reactivity instead of asynchronous, which solves completely different problems than promises and observables do, and is really valuable for state management. So why do we need this at all? It's because asynchronous programming is hard. When we all learned programming, whether it was in third grade or in college or whenever it was, we learned synchronous programming, something that looked like this, where there's a function, and within that function, we make a call to another function A. And we get some result from A, and then we can pass that into B, and get the result from B and pass that into C, and get that result and pass it into D. And then finally, when we're done, we can take that result and log it to the console. And things happen one after the other, A, then B, then C, then D, then the log, and we're done, and it's easy. And this is great for learning programming. Unfortunately, it's not real life. Because in actual programming, we deal with many different sources and many different APIs of asynchronous data. We have to deal with the world as it is. It could be HTTP calls, where we make a call to some server, and who knows how long it's going to take with network lag for that server call to come back. We might have a WebSocket that opens a continuous perpetual connection to the backend, and who knows when the backend is going to send us data. And every time it sends us a new value, we have to respond to it. It could be disk access, just reading a file from a disk. Who knows how long that's going to take? Could be user input. Who knows when or if a user is just going to start typing on their keyboard? It could be mouse motion. Who knows when or if that mouse is going to move? And we want to react to know every single time that mouse moves for gaming or whatever. And there are many, many more sources of asynchronous data, asynchronous streaming, and many different APIs for all of these. Initially, they all kind of had their own approach because they were all developed independently. And so the approach that you would use for HTTP wouldn't be the approach you would use for mouse motion, and you'd have to remember a whole bunch of different APIs. Most of the APIs ended up using callbacks. So in this case, unlike what we had before, where we could call A and immediately get the result, this call to A is going to take some time. And we want to do something with the result from A whenever it's done. So we make a call to A and we pass in a callback. And we pass in this function that gets called when A is done, and then A, when it's done calculating, can give its value to us for us to do something with, like log it to the console. And when we have something simple like this, it works really well. We make our call to A, it calculates, it gives us our result, and then we can do whatever we want with it. But it doesn't work so well when we want to chain these things. We want to make our call to A and get that result in a callback, and then within that callback, call B and get the result from B so that we can pass that into C and then have another callback and then do the same thing for D until we get our console log. And this works, but it's hard to read. It's hard to reason about, and people ended up calling it the pyramid of doom. So we want to have a better way of doing this that allows us to chain these things, that allows us more complicated interaction with asynchronous programming. And the first approach was promises. So promises still use callbacks, but the key insight is that it separates the call from the callback. So as before, A makes a call, or it does some processing, and when it's done, we get a result that we can do something with. But instead of that callback being in the call to A, it is deferred to this function called then. So whenever A is done, then it will execute whatever we get in the callback. So we call A whenever it's done, then we get our result from A, and we can pass that into B. And whatever we return from A, must use the results from A, and then when you're done, we can use that result and pass that into C, and then when that's done, et cetera, et cetera. We still have the same number of callbacks we had before, but it's much easier to read on our screen. We're able to separate the call from the callback, so we're able to chain all of these calls together, and we have much better semantics and better developer experience. And we can improve it even more by using some syntactic sugar called async await. If we slap the word async at the beginning of our function, then all of these places where we'd have our promise before, we can use the keyword await. And now we can await that, pass that into C, and await that, et cetera, et cetera. What we end up with is code that looks a lot like what we started with as the ideal, easy way that we all first learn programming. We just need to say we're asyncing it. This is asynchronous code, and we're awaiting each promise along the way. And that's almost all we need to do. There is one other consequence of this. Anytime you use async on a function, it becomes a function that returns a promise. In this case, this function doesn't return anything, but it still has to return a promise because we're using async on it. So instead of just being a return of void, it's now a promise of void, which means now anything else can call do it and either call then on it or do an async await on this do it to be able to defer the processing as necessary. But otherwise, this is much simpler than that callback hell that we had earlier. We also get error handling with promises. So, what if something goes wrong when we make our call to A? Well, then we can catch that error. So, it'll go into then if A processes correctly. But if it fails, if there's some sort of exception that gets thrown, it'll instead go into the error path. And we have a finally, either way, whether it's the then for a success or a catch for a fail, it will drop into the finally, and that will be a good spot to do any cleanup we need. And we have a similar type of thing for async await. By using an await, we're allowed to use the try, catch, finally semantics that are very common in C-based languages that make life easy for us. We just have to remember to put that await on there, and now within our try block, we are awaiting things. And if that exception happens, it drops into the catch, just like any other exception, but it's still deferring things. It's still using asynchronous programming. A big area that we use promises is HTTP calls. We now have the API for fetch, where fetch allows us to make a call and it returns a promise for us. So in this case, we are going to make a fetch call to this URL. It's on the Star Wars API call. And when it's done, then we will get our response. And we can do whatever we want to in that with response. And in this case, we'll can extract some JSON, return it, and that will give us another promise. It doesn't have to do it that way. We could all do this in that first callback, but we return this JSON. And even though the .json doesn't return a promise itself, because we're returning a promise from a promise, that value is wrapped in a promise, and so we can have our then chain. So our first then, we have our response, we get our JSON out of it. The next one, we dig into that JSON as we need to. And then finally, we can console log our result. And the upshot of all this is we get to see the information about R2D2 because that's what this API returns for that call. And if there were an error in here, we could catch that error. We also have cancellation, but not with promises by themselves. It's only in certain circumstances, but fetch is one of those, where we can use something called an abort controller to cancel our fetch. And this is not something that promises usually have, but in this case it does. So we can pass in to our fetch call, in addition to the URL, a signal that comes from the abort controller. Now, don't be confused. The last half of this talk, I'm going to be talking about signals. And here we have the word signal. They're completely different things. English uses words over and over again. So it doesn't mean the same thing as the signal later. It's just a signal to the fetch that this is the thing that can be aborted. So in this case, we have set up our fetch, we set up our abort controller signal for our cancellation, and then you can see at the bottom, we have a timeout there. After 10 milliseconds, we will abort using the abort controller, saying the reason we're aborting is just because. And 10 milliseconds is quick enough that the result had not returned from the server, and so that abort dropped down to our catch, and we logged to the error console the just because. So in summary, promises give us asynchronous reactive programming. It's very standardized, native in all modern browsers. It's cancelable with the help of an abort controller, and it gives us a single value, which is ideal for an HTTP fetch call. But what if you want multiple values? That's where observables come in. So I like this little matrix as a way to think about observables. There's a lot of analogies we use when we're thinking about observables. So what we can think about is in synchronous programming, just normal programming. If we have a single value, we'll put that in a variable. But if we have multiple values in space, we'll put that into an array. Well, with asynchronous programming, we have a single value that we're going to handle. That'll be a promise. But then what do we want to do if we want to have something like mouse motion or a WebSocket where there will be multiple values over time? That's where the observable fits in. And this analogy is actually fairly strong because a lot of the things that we do with arrays, like mapping them, filtering them, that sort of thing, we can also do with observables. And I'll show some of that later. So the niche for observable, really any stream that has a lot of values over time. So a WebSocket, as I say, you can set up a permanent connection to find out stock prices. So every time the stock of Google changes, you get a new message from the server that the server pushes. Or user input, who knows when users will type. Or mouse motion, who knows when and where the user will touch their mouse. Or any events from the browser, or really any stream, or importantly, any combination of streams. It's pretty powerful. And the history of this, it actually comes from Microsoft. In 2011, as part of .NET, Eric Meyer created reactive extensions to create observables for .NET programming. And it was based on the observer and iterator patterns, a combination of those. And it was so powerful, it quickly spread to other ecosystems. You can see the list of them on the right. The important one for us is RxJS, the second of those. And it was out there for a while, but it really got a lot of attention when Angular 2 adopted it for its use in the new Angular version back in 2016. And today, RxJS, or the reactive extensions for JavaScript, is the de facto standard in JavaScript. But it's not truly a standard. And there is a standard in the works. It's early in the phase, but there is a standard in the works that you could follow this link and see information about that. And currently, native observables are supported by Chrome, but last time I checked, not in any other browsers. So my company isn't Chrome only, so we're not using the native observables yet, but you might be able to use native observables. But since I know mostly RxJS, I'm going to talk mostly about RxJS and occasionally just talk about differences with native observables. So how do we create an observable? Well, there are a lot of ways to create them. And I link at the bottom and with the QR code, there's a list of a whole bunch of creation operators. But the simplest one I know of is called of. So you can say of from RxJS and put anything you want in that. I'm going to create of hello. So now I have an observable that has the single value hello. What do I do with an observable? How do I get anything out of it? Well, you subscribe to it. Similar to the then on a promise, but it behaves a little bit differently. So now we can say, all right, with our observable, I want to subscribe to it, and then I can give it a callback, in this case, console log. So I'm going to log out hello. This is a really complicated way of getting a console log on the screen. It'll be more useful later. And then I add a console log at the bottom to show that because of is essentially synchronous, it happens so quickly that it gets emitted before the line after it. So this is kind of weird. So we have this single value synchronous, and I'm talking about something that's supposed to support multi-value asynchronous. Why do I bring this up? Well, one, it's an easy way to create an observable. And where it's really powerful for me and my team is that we use it in testing a lot. If I have a unit test that I want to have something that processes an observable, the easiest way to observable is to wrap something in of, pass it to my unit test, and the unit test doesn't know that there's only this one single value, but it exercises the behavior of that observable. Interval gives us a more realistic version because this actually is asynchronous. It gives us multiple values over time. So again, I get interval from RxJS, and I can, when I call it, using this creation operator, I get an observable. In this case, it's going to be something that emits after 1,000 milliseconds, and then every 1,000 milliseconds after that. So every second. So here we have this observable. I'm going to subscribe to it and console log. And now you see the values 0, 1, 2, 3, 4, 5 that will continue after that. And those are coming from this observable. But notice that finished actually gets emitted ahead of it, above it. And that shows that we really are dealing with asynchronous programming. Even though the line that shows finished is below the subscription, it gets executed first because nothing comes out of this interval until a second has passed. The finish gets emitted immediately, gets logged immediately, but nothing comes out of this interval for a second, and then another second, and then another second, et cetera, et cetera, et cetera. So this isn't too powerful yet, but this is showing that we can create an observable that has multiple values over time and subscribe to them and have something that processes it and handles each one as it comes across. Promises can't do that. If we wanted to do something like this with a promise, we then it and then have to create another promise to wait a second, and then in each side, each then we'd have to set up another promise. It would be a huge mess. But observables, it's very easy. Another place that we can create observables from is from events. Imagine in our application, we have a button, and then we can use our document to get that element from it. And we can say from event, from RxJS again, we can wrap the click event on that button and subscribe to that. And now every time the user clicks on that button, we'll log out the details of that event, you know, the XY coordinates and whether the control key is depressed and things like that. This is another way to create events. And now that we have 3 different observables, 3 different streams, we can combine them. And there are many join operators. I'm only going to show one, but again, the link at the bottom shows you a lot more. So we could create a single value of hello and our interval of numbers and the button click, and then we can merge them using the join operator of merge them at the bottom. And so now we will immediately get a hello, because that happens immediately. And then after a second, 0, 1, 2, 3, 4, 5, and interspersed in all of that, anytime I click on that button, those will be in there. We'll have a single stream that'll have these 3 different sets of data. Now, this particular might not be that useful. Like, when would you want a hello and a bunch of numbers and a button click? But the tool is extremely powerful, because you can combine data from this server and data from this server and combine them together with maybe mouse motion or whatever, and process the mouse motion and do things as these things happen. And this merge just emits them all. Anytime any of the 3 things that come in, it re-emits them. But the other join operators have other behavior that lets you combine them and do logic based on them. So there's a lot of power that comes from this. And unlike what the historical APIs were, we have one API for this. It's just a subscribe. So doesn't matter where the source is. All of these observables from all of these different types of streams, we handle the exact same way, which makes our lives as developers a lot easier. Unlike promises, observables have cancellation built in. The way you do your cancellation is through the subscription. So as before, I subscribe to this observable, but now when I subscribe, I'm going to grab the object that it returns, a subscription object. And then after I log the console finished, I'm going to have a set timeout to unsubscribe from that subscription after 2.5 seconds. So this will process through, it comes through, and immediately we say finished. And after a second, we see the 0. After another second, we see the 1. And half a second after that, we unsubscribe and we end the observable. And this is actually really important. This is not the only way to unsubscribe. There are a lot easier ways and things that are built into Angular, like the async pipe that'll handle it for you. But it is important to unsubscribe when you subscribe, because if you don't, you've created a memory leak. So you don't have to worry about that as much with promises, because there's a single shot. But observables, if you don't do anything to take care of them, they will just keep your memory forever. So make sure to unsubscribe when you subscribe to handle your memory leaks. And now we're going to get to some of the power of observables by manipulating our streams. So as these values come through, we're not stuck just handling them as they are raw. We can do things with them. So in this case, I'm going to have my interval. Again, it starts out with 0, 1, 2, 3, 4, 5. And then I'm going to pipe some operators on it to add some things that change. I'd like to think of this as, imagine there's a literal pipe with water coming from the ceiling to the floor. And then I have spots where I can change things. I have valves that I can turn. I have shelves that I can open up and toss in things. I can change the water to Kool-Aid by putting in powder, or I can turn a valve and turn it off and do all of these different things. That's what we have here. So the first operator that I'm going to use on this is the filter operator. So again, the values coming in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, forever. Now I'm going to filter it and only allow the values that are less than 6 to come through. So now it's 0, 1, 2, 3, 4, 5, and then we don't see anything else. We haven't unsubscribed. The observable is still creating those things. We've just turned a valve, and we're not seeing anything more out of that. And then after that, I'm going to do a map. What map does is it replaces every value with a new value that gets returned. So it's going to get the old value, and I'm squaring it, multiplying it by itself. So now instead of 0, 1, 2, 3, 4, 5, I get 0, 1, 4, 9, 16, 25. And we can combine these and do a lot of things with this. Few interesting points. The order matters. If I swapped the order, if I squared them first, I would get 0, 1, 4. Oh, I never will see 9, because I'm going to, if the filter came later, it would filter out the squared values, not the original values. So the order matters. It is an order of operations. It's going to hit the filter first, do that, and then hit the map. Other thing of interest, This is a difference from native observables. With native observables, it looks more like an array where it would just be interval dot filter dot map. So the chaining structure is different. And this has to go into tree shaking and a lot of different things. But when they control the language, they can do more than RxJS can do from the outside. So in RxJS, we chain them with commas. The native observables, they chain them with dots. The other thing that you might recognize filter and map if you're familiar with using JavaScript arrays. It's the same basic concept as the filter and the map for an array, except instead of filtering out each value in space or mapping each value in space, we're filtering each value that comes through in time or mapping each value that comes through in time. So it's very analogous to arrays, but slightly different meaning. And then we get to the interesting question of higher order operators. So imagine what we want to do is have a set of numbers that do 0, 1, 2, 3, 4, but then restarts. So every second we get 0, 1, 2, 3, 4, but after 4.5 seconds, we start over again. So we want 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So you might think a way to do that is what I show on the screen here by using a map to convert each value that comes through. So every 4.5 seconds, we'll get a 0, then a 1, then a 2. Convert each of those to a new interval. And you might think that would work, but it doesn't. The reason it doesn't is map replaces the previous value with whatever the new value is. An interval doesn't return those numbers. Interval returns the observable that contains those numbers. So instead, what we get is every 4.5 seconds a new observable showing. And that's not what we wanted. But this is what most people try when they want to try to solve this problem. What we need is something that is a higher order operator that is more powerful than map. And we can try merge map. Merge map is a higher order operator that works like map, except it has a flattening operation. If it gets an observable, it will flatten out that observable and take the values out of it. So instead of having an observable of observables, we'll have an observable of the numbers because the numbers inside of it will get extracted. Basically, anytime you might look at something like this and say, oh, I have an observable inside, I want to put a subscribe inside of a subscribe, that's an anti-pattern, that's a smell. Don't do that. Use a higher order operator instead, which will do that flattening for you. So now, does this give us what we want? Well, closer, but no. It starts out right, 0, 1, 2, 3, 4, and then 0, great. But then 5, 1, 6, 2, 7, and by the end, like 1, 6, 11. What's happening? What's happening is that merge map is doing exactly what it's supposed to do. It is merging in these new intervals together, but it's never canceling the old ones. Yes, we're doing 0, 1, 2, 3, 4, and then another 0, 1, 2, 3, 4, but it's the 5, 6, 7, 8, 9, 10. Those are still happening. So what we need, and sometimes merge map is exactly what you want, but not what I said I wanted this time. And in this case, what I want instead is switch map. So switch map, every time it gets a new observable, cancels the old one. It switches from the old one to the new one. So we'll say 0, 1, 2, 3, 4, new observable, switch to it, cancel the old one, 0, 1, 2, 3, 4, new observable, switch to it, cancel the old one, 0, 1, 2, 3, 4, etc. And this is a really high, very brief introduction to higher order observables. If you want to see more, I highly recommend the link at the bottom here. It was a talk given several years ago at NGConf, a 20-minute humorous sketch about switch map, which I didn't think would ever exist, but it did, and they did a really good job. So I recommend giving that a shot. And these operators are the power of RxJS, but they're also the confusion. There are dozens of them. There are so many of them, probably over 100. And there's a lot of guides to help you understand them. The first link is if you're a like to read text, if you want to really read and understand exactly what combine latest or fork join or any of these other operators mean, if you really want to read it, that's a great link. If you're a more visual learner, RX Marbles is a good website because it shows marbles that show moving things around and shows with a filter that some of the marbles won't get through, or with a switch recovering this one marble to these marbles and then canceling and switching, et cetera, et cetera. Or if you know you want an operator and you're not sure which one it is, the next link is what I call choose your own adventure. It's a decision tree where you can click on it and say, all right, I know I want to combine two operators. And so you click on that, and then it'll ask you questions, and you'll say, all right, I know I want to calculate a new value based on both of them. Click on it, and that it won't emit anything until all of the source observables have emitted something. And you click on that and eventually find out, oh, combine latest is what I want. What does combine latest mean? Then you can look at the text or the marbles in order to get a better understanding. But you don't have to be overwhelmed. I really like this article on the last link. It recommends 7 operators to start with. And if you understand those 7 basic operators, you can get really far in doing a lot of things. Now, it turns out some of the other operators will be simpler ways to do things that you can figure out on your own with just those 7. It might be, you can what you're doing with 3 of those operators, there's another operator that is exactly what that needs to do. But you don't need to worry about all those other ones. Just start small, get confident in a basic set that can do 90% of the work, and build from there. So in summary, observables give us asynchronous reactive programming. They handle 0 to many values. They're inherently cancelable. It's important to unsubscribe to prevent memory leaks. I showed the unsubscribe direct, but there's also some operators like take and take until that do unsubscription. It is not as standardized as promises, but it's working there. And library, the RxJS is like the Lodash for events. And you might think that RxJS is feeling threatened by the existence of the new native standardization, but it's not true. If you follow that discussion, you see they're excited. RxJS wants to get out of the observable business, and they want to get into the operator business. They only want to focus on the operators and let the native library handle the observables themselves. And if you want to know more about native observables, I recommend this talk by my friend and fellow Angular GDE, Rainer Hanekamp, and he goes through with more examples comparing them. So with that, it's time to talk about signals. So what are signals? Signals hold a value and notify consumers when the value changes. It's not much. It's like a box or a cell that has a value, and it knows if this value changes, it knows how to tell other things. Hey, by the way, I changed. And that's really it. But a lot of power comes from that basic idea. So going back to this matrix, where do they fit in? We already have a variable and a promise, an array, and an observable. So where in this combination do they fit in? The answer is they don't. It's the wrong question. They solve a completely different problem than promises and observables do. So a way to think about the problem that they solve, which is helping frameworks keep the DOM, or the document object model, what the users see, helping them keep that up to date, is to think about early gaming. When games were first written with really slow computers, the easy way for developers to write them is that every time anything changed, whether the user typed in a new command or made the player move around on screen, the easy way to do it was to regenerate everything and send the whole thing to the screen. Easy programming. You just have to, all right, something's changed, send it all in. But it was slow because usually only a tiny bit of the screen would actually change. If our little figure moves from here to here, why are we resending all of this stuff? So it was extra calculation, extra data going across the wire. It was just slow. So that approach was called immediate mode, or full screen re-render. And what they figured out is they could do something called retained mode, or incremental re-render, whereas if this is the whole screen and this is the only part that actually moved, Okay, we say put a little rectangle around the part that moved and say, all right, this is the information. These are the bounds of what moved, and just send that part and let the client know that the rest of this didn't change. So we can send much smaller bit of information to the client. Much better for the users, but more difficult for us as developers because we have to figure out how to do the bounding rectangle and calculate it and separate things and do partial application of data and stuff like that. The goal with signals is to give us the fast behavior, the fast behavior of retain mode, but allowing the coding to be more like immediate mode. So easier for the developers, but still fast for our users. So here's a simple calculation that I use to explain what signals are doing. There's no need for signals yet. Later, I'll bring in signals. But imagine we're scheduling a party or a wedding or something. And we know that we have 50 guests. Great. So we want to reserve a room. And we ask how much it costs. And it turns out that that room has a volume discount. If you have fewer than 60 people going in, it's $30 per person. But if you have more than that, it's $25 per person. So we know we have 50. We know our number of guests is less than 60, so it's going to be 30 per person. We can calculate our total of the number of guests times the cost per guest. All right, 50 times 30. We can log out that total, 1,500. Easy calculation, back to our synchronous code, one thing after the other. But what if we realize every guest we invited is going to bring someone with them? So after we've made our calculation, we want to recalculate. Now, if this is a simple function, you can just pass in 100 again. Sure. But what if we are doing this for putting something on the screen and we don't want to recalculate everything? We only want to recalculate the things that need to be calculated. We want to figure out exactly what needs to be recalculated when part of the input changes. That's a lot more difficult. How do we know what to recalculate? How do we recalculate cost per guest and total? How do we indicate that those need to be recalculated? And more, how do we make sure it happens in the right order? Because if we only recalculated the total with our new num guests, we would have our cost per guest wrong. Cost per guest would be stale. It would be obsolete. It would still think it's 300 or 30 when it actually should be 25. And so we could get the wrong calculation. We could say the new value is 3,000 before recalculating everything and realizing, oh, it's 2,500. So we might end up on our screen having a glitch where it shows 3,000 and then quickly corrects itself and shows 2,500 and just annoys our users. Yeah, we call that a glitch when we have this timing problem of how do we know which parts to recalculate. And we've seen, all right, my script, whoa, there we go. There we go. We have seen solutions to this. There's something that we use, almost all of us probably use almost every day, that gets this right. It's a spreadsheet. Now, I'm not saying Excel or Google Docs or anything was written with signals, but it's essentially the same problem. And if you think about a spreadsheet, you can think about what signals do for us. So here's another calculation for number of guests. That's more complicated because it brings in taxes and discounts and other things. But anytime you would do this in Excel or Google Docs, whatever, when you change the number of guests, it immediately figures out everything below it that needs to be recalculated and calculates it immediately. When we change the cell that has a value, the things that depend on it get changed immediately. And we don't need to do multiple calculations. We don't see glitches where there's partial calculations. We make our change, everything that depends on it below it immediately gets updated. That's what we are aiming for with our Angular code. And this sort of problem of figuring out how to get our DOM to reflect our state is a problem that all the frameworks have, and many of them have converged on the same basic approach. Huge list of them here. And it's kind of like in biological evolution. If you looked at all of these crabs, you might think, oh, they all have a recent common ancestor, but it's not true. They evolved from forms that looked very different than these, but it just happens that having 6 legs to scurry about and 2 chompers at the front to grab things is a very, very good way to survive on the bottom of the ocean. So there's been convergent evolution on that. Similar thing has been happening with frameworks. A lot of different frameworks have been converging on signals. Notice a big player that's missing, React. React is going in a completely different direction with hooks, but most of the other frameworks are converging together. So I'm going to talk about a few of them. There's more details in the link at the bottom here and the link on the next few slides, but I'll just talk about a couple of them. The first that got pretty close to this was Knockout. About 10 years ago, it got close, but it was glitchy. It still needed extra cycles to recalculate. And it got the last piece of what it had in 2014. The first that had it right with getting glitches fixed was MobX. It used something called push dirtiness pull value, which I'll explain later, and dependency tracking, like that thing to keep track of which things to calculate in what order. By combining those, it got it right back in 2015. But the first framework to pull it all together as something called signals was Solid.js, which you might not have heard of. Solid, unlike some of the bigger frameworks, Solid.js is just run by this guy, Ryan Carniato. Seems like a really nice guy. I've never met him. He's the guy who wrote the blog post that is linked at the bottom that goes into a lot more of the detail of this history. He brought this together and he showed how signals can be used as the main mechanism for state management. But when it's just one of hundreds of JavaScript frameworks and it's just this guy, people don't really pay much attention until Angular picked it up. And Angular isn't as big as React these days, at least not in America. But it's big enough that when Angular picked it up, that got a lot of attention. And you may know, I don't know if you've had discussions about this at your user group, this other icon here, this W, this blue W, what is that? That is the icon of a framework called Wiz. It is an internal framework at Google. So Angular is what they use for their external sites. It's what they've shared with all of us in the rest of the world to use. It is really good for developer experience. Wiz is really good for performance. It's what they use for Google Drive, YouTube, Gmail, stuff like that. But apparently the developer experience isn't great. Those two frameworks are what they use internally at Google, and they are converging, which means when Angular picked up signals, so did Wiz, which means the same signals that Angular uses are what you use in YouTube right now watching this. And with this convergent evolution, there has been some standardization. So we don't have to worry about everyone doing something differently. Again, this is in a very early stage. And interestingly, the initial prototype was built upon the Angular implementation. And you can read more about that process by the link at the bottom. So now that I've kind of hand-waved, what does this mean? How does this help us out? Let's go back to our number of guests problem. So now, instead of just having 50 as our number of guests, we're going to wrap that in something. So we have a signal. So we have a signal that holds 50. And then cost per guest is now going to be computed. And we can use a callback to say, all right, I want to calculate this. Give me whatever value num_guest has. All right, 50. Compare that to 60. All right, we know our value is 30. So that is the value in the cell or in the box in the signal for cost per guest. And then total will get calculated by 50 times 30 again as before, and that's the value it will have. And we're going to have an effect, just something to prompt all of this to execute. So we will get the value out of total and log it. Great. But now we change that number to 100. What happens at this point is we change the value for num_guests. And this is where that thing I mentioned with push dirtiness pull value comes into play. When we change the value to num_guests, all right, it gets a new value, but the important thing is it gets marked as dirty. And it tells anything that depends on it, I'm dirty, so you're dirty too. So that tells cost per guest, you're dirty now. And that tells total, you're dirty now. And then total tells the effect, I'm dirty, and effect says, all right, you calculate yourself again. Now that the effect is asking for that value, it's going to pull the value down. So total says, I need to recalculate. What do I need? I need the value from num_guests. Oh, that's 100. That's easy. I need the value from cost per guess. That was dirty. Cost per guess, recalculate yourself. It does, using the num guess value, gets a value of 25. It does the math, and we get the right value. So num guess, the dirtiness gets pushed down till we get to that effect. That effect says, I need to have this value to be able to log it out. Recalculate yourself, and then it recalculates up, grabbing the values and forcing everything to recalculate as it needs to, once and only once on the way. So we have little caching in all of these things, so we only recalculate when we need to, and we get the right value with a glitch-free operation. Dependency tracking to know the right order, and push-pull semantics. That is what signals give us. And the API for all of these will vary. I'm going to go through this a little bit quickly since this is an Angular group. To create a basic signal in Angular, we would say signal of 0. You can see the APIs in some of the other frameworks. When we want to set a new value, we have that count, and we can call .set, pass in a 2. Again, different versions of different frameworks. When we want to have a computed signal, we'll use a callback. They're not dead, they're just managed better. So now the second line, we'll see our Angular thing. We'll wrap a callback in the word computed, and then we'll have other signals in there, and that gives us a signal that will recalculate whenever its dependencies are changed. And when we want to get a value in Angular, we just put parentheses at the end. There are other ways to do it as well. And you might be worried that, okay, all of these different implementations, Angular does it one way, but Preact does it another. Which way are they going to settle on? Are Angular developers going to have to learn what Preact does, or vice versa? It's actually only the core of it is going to be part of the standardization. At least that's the goal. The actual implementation, those APIs I just showed you, Angular can do its own thing. Preact can do its own thing. Solid can do its own thing. The internal implementation will be shared. But as Angular developers, we'll get to keep using what we're used to with Angular. But there are also some things that are not going to be part of that standardization, like effect that I showed earlier. That doesn't actually exist in their standardization, but Angular has it. So looking at a simple Angular example, here we have a small component that has a door, and the door is open or closed. And so we have a Boolean, open or closed. If the door is open, we show a welcome component. If the door is closed, we don't show it at all. And we have a button that you can click the button to toggle whether the door is open or closed. The state of this, the only true root state is that door open. And in old Angular, we would have implemented that as door open equals signal. Door open equal true. But now we'll wrap that true in a signal, and now we have a writable signal, something that we can change. So now in our template, if door open, use parentheses to get the value out, we'll show app welcome. And then for our button, we want to show the button text. Well, that is from this computed signal. It's a derived state. So we have this computed signal that takes a callback that gets the value from door open, starting out true. So since the door is open, this is going to say closed door. The magic comes in when the user clicks toggle door. The click handler, that's going to execute this, and it's going to use the update part of the API from Angular to give us the old value, negate it, and put it in. So if it was open before, now it's closed, vice versa. So we are changing the value of that signal, which means we're making door open dirty. So the first line of the template, door open, is marked as dirty, and the button text is marked as dirty. And both of those are going to tell Angular, these specific lines are dirty. Re-render these specific lines. Not all of that is in place yet. They're still working on it. It's more coarse-grained than that. But the ultimate goal is that Angular will be able to know this individual line in this component and this individual line need to be re-rendered. Nothing else does. So we're getting that better behavior like we wanted from the gaming programming of only updating exactly what needs to be done. And it's not as simple as just using a Boolean, but it's not that bad. And it's a lot easier than a lot of the other approaches. So we're getting towards there. Signals give us this push, pull semantics, and direct information that Angular knows exactly what it needs to re-render. So how do signals improve the developer experience? No risk of memory leaks like subscriptions, one-way data flow, memoization, it caches it, and glitch-free operations through the push-pull and the dependency tracking. So now that I've talked about both observables and signals, which to use, you both it. They solve different problems, so you use them where it's appropriate to use them. As Ben Lesh, who's the head of the ArcGIS team, said, use signals for state, observables for events is pretty simple. The opposite is silly bad. There's a division of labor. Use your observables or sometimes promises for events like event streams, complex asynchronous operations, anything time-based, advanced operators, HTTP. We use signals for your state management, your binding to your templates, your glitch-free data flow. But there's going to be a gap there. And I'm going to show from the Angular perspective where that is. The first way that Angular gave us to bridge the gap are these converting functions. So we can have a value observable and convert it to a signal, or have a value signal and convert it to an observable, going back and forth. And what we end up with in this early version, when these were all the tools that we had, essentially the templates would be in signals, and then all the communication to the back end, to the server, would be observables, and then we'd have a layer in between that was doing a lot of to-signal to observable conversion. So an example of seeing this, imagine we have a bookstore and we say, which book do we have selected? Well, the selected ID is going to start out as a signal. And then we want to use that ID, whatever ID was selected, to make a call to the backend to get more information about that book. Signals can't do that. Signals can't wait for a laggy call to the backend. So we need to convert it to an observable. Once we have that, we can filter and switch map, make the call to the backend, wait for everything, get that result in our observable, and then do a signal at the end so that we can log it out. So, here I'm doing it as a console log, but essentially think of that as your template. The template will be signals, the backend calls will be observables, and we do these games of swapping back and forth. Fortunately, Angular gave us a better approach with resource APIs. So this resource API, in this case is Rx resource, starts out with a signal and ends with actually a bunch of different signals that are wrapped together, but manages all of the observable and time-based stuff for us, so we don't have to handle it. So we're going to wrap all this in an Rx resource. We're going to have our initial parameter of this selected ID signal again, and every time that changes or it gets executed, it's going to be passed into the stream to this caller on the back end, and internally it's doing the switch map and the waiting and all of that for us. And then at the end, we have a signal on the resource that we can use to put it on the screen. We also have has value to know if we have that, and there's whether it has an error and loading. This resource gives us a lot of tools that we didn't have before. So I've talked about how we'll use signals and observables, but remember, promises still have a niche. Looking back at this grid, it's true that observables are more powerful than promises. And so some people say, I only want to use observables then. But it's no more true than arrays being more powerful than variables. And I don't see anyone wrapping every single variable in an array just because it has more power. Promises are the right thing sometimes and the simple things to do. And just remember, the particular niche is fetching. HTTP calls are single shot. It's perfect for a promise. So use it for fetching when you're just doing a simple get if you can. But otherwise, observables are more powerful for other streams. So in summary, promises and observables are asynchronous, signals are synchronous. Promises have one value, observables have 0 to many, and signals have 1 at a time. Promises are fully native, observables are working on it, and signals are further away. Promises don't have cancellation built in, but sometimes with a friend they can be canceled. With observables, it's built in with switching, and signals, it automatically cleans up for itself. For utilities, promises doesn't have much, but it doesn't need much. Async await is the big thing. Observables, all the RxJS operators, and then signals, it's going to depend on the implementation. And from Angular, we have the Angular tools. And the niche for promises, HTTP requests. The niche for observables is event streams, WebSockets, multiple values over time. And the niche for signals is reactive state and keeping your DOM, your template, up to date. And thank you. And here again are the slides. And there's my talk. Anyone have any questions?
It looks like we don't have any questions for now.
Okay. So I believe I'm going to be back in 2 weeks, and I'm going to be talking about the recent changes in Angular, the Angular Renaissance. I'm going to be talking about half of that talk is going to be about signals again, but it's going to be much more Angular focused, not as much about the history of signals, but like going more in depth into the APIs of signals with Angular, along with some other Angular recent changes.
Okay. Does anyone have a question before we close? Actually, this was a pretty interesting session for me. I'm a front-end engineer myself, and there's some things I had forgotten about, so it was a really good refresher. Yeah. Yeah.
Yeah, I would hope that a lot of the information about, especially about promises and observables, is review for most Angular developers. Signals is the newer thing, and so it's what a lot of developers tend to be more interested in, which is why the promises and observable sections of the stock are shorter, and signals is where I really dug in.
Yeah. We just have a couple of guys who are saying thank you. Yeah, it was a pretty interesting session. I actually really enjoyed it, Lance. So I'm looking forward to the next one.
It looks like Tayamba
Okay, so
has a
there's a
question, but is typing it out. So
yeah, yeah.
Yeah, I think as Tamba is typing his question, I think just want to appreciate Lance as well on giving like a very, very good analogy. I've done also a session with regards to observables, and I once used the analogy of water pipes to explain the concept of streams and observables. So it was really good to also see the analogy over here. It really puts things into perspective. So that was really great.
yeah. I got a lot of that. A lot of what I talked about with observables from a friend of mine who's also a Google developer expert named Corey Ryland. He does a full hour talk on observables that goes into a lot more depth of like what's actually going on the inside. But yeah, one of the things with observables is there are so many metaphors for it, so many analogies like the pipe, and they're all wrong. Observables aren't really a pipe like that. They're not really arrays. But I find them to be helpful analogies, if you understand the limitation of the analogy. All right, Tayamba, how do I feel about unwrapping a signal in the template using let, or do you prefer to call the signal everywhere if it's used in a template? I love let, and I will use that. I don't use it every single time, but it's similar to if I'm writing any other TypeScript code and I have I need to make a call a bunch of times. You can extract that to a variable. I will do that in my templates. So if I have a particular signal that I use 2 or 3 times or more than that, I'll use an @let in order to have a single variable instead of having to fetch it each time. But it's not a performance gain because of the memoization, the caching that happens in the signal. There's no actual performance gain. Like there would be if you were trying to do a call and you don't want that call to happen. It's really more of a just wanting to get rid of the duplication of code. So it's more of a personal style preference. I have a coworker who disagrees and doesn't want to use it in that case, but I like it. Yeah, and then, oh, one more question coming. What do I name the signal versus the unwrapped version? I don't have a standard for that. And I have not seen a convention be created. Like with observables, sometimes there's the convention of putting the $ on it to indicate that it's an observable. I haven't seen anything like that with signals. Yeah, if the signal is called book and I want to use the let to name a variable that's also book, I don't have a great name. I mean, B, but that's not great, or the book or something. But no, I don't have a great example. Someone just asked, is there a timeline for native support for signals in Angular? Well, not that I've heard of, but it's not actually going to matter. It's all going to be an implementation internal. Assuming that that standardization process completes. It's early enough, who knows, it might not complete, but it's just going to be an internal implementation. And so, you know, the Google team will know that they changed it from one thing to another, and things that where they currently write it themselves will have to be adapters in their code. But it's, from everything I've heard, it's not going to affect our code at all, so it won't actually matter. More to matter will be using native observables if you have that. And that's going to be a slower transition because there's just so much RxJS code out there. I don't know if or when Angular is ever going to convert to native observables. I haven't heard anything about that. All right. So if that's all the questions, thank you and have a good evening. And I'll see you again in a couple weeks.
Thanks a lot, Lance, for taking the time to share the concepts. We had fun. I had fun. And thank you to everyone who joined us. Oh, there's another question.
Is it really useful to use effect in signals? Yes, there are times that it is exactly what you need to do. So you can think about an effect as kind of like subscribe, a manual subscribe on an observable. In general, with Angular, we've been taught for a long time, try not to manually subscribe, use the async pipe. And that's true, but you can't use the async pipe for everything. It depends on where your data is going to. If you are subscribing to something to get it into a different form to send it to the backend, there's no async pipe to put it on. So there are times that as a developer with RxJS, we need to manually subscribe. Similar, there are times that we need to use effects with signals when we have side effects that we want to handle. The Angular team encourages people not to reach for effect first, to look at computed and linked signal first, because it can, especially if you're using a signal, an effect to take a value from one signal to put it into another signal, it can cause problems with like infinite loops and things like that. So when you can rewrite your signals as computed and linked signal, or use the resource APIs when you can. But there are times when I just want to log something to a console whenever this signal changes. I want to do a console.error when an error signal happens. The effect is the exact perfect spot for that. So, thank you for your question.
Okay. Should we give people a minute? Maybe there's another question that will come up, or
I can wait a minute.
Okay. If you have a question, just now is your time to shine. Okay. Thanks a lot, Lance, for again taking the time to share with us. It was a pretty interesting session. I think anyone could, from any level, I mean, any developer who's at any level, beginner, advanced, maybe has taken away something from this session. To everyone who's joined us tonight in Kenya, thank you so much. And all the others who've joined us tonight, thank you as well. So allow me to close this session for today. Thank you and see you on the next one. Bye.